Welcome to the fourth lesson of our fourth unit, Acute Angle Trigonometry, in our grade 11 University College math class. Today we are going to be working on solving problems involving two right triangles. So basically this is sort of the last lesson in what I'd call the first half of this unit. The first half of this unit deals exclusively with right angle triangle trigonometry, and the three tools that we've developed as part of our right angle triangle tool belt are the sum of interior angles, where we know if we know two of the three interior angles of a triangle, we can figure out the third one. The Pythagorean theorem, if we know two sides in a right angle triangle, we can use the Pythagorean theorem to find the third. And primary trig ratios, where you can find either sides or angles depending on what information that you're given. So today, it's sort of a bit of a free-form one where we're going to try to find a piece of information using all the tools at our disposal in a situation where the thing that you are trying to find isn't available in one step. We need to have a bit of an approach to this. So this first paragraph here, which I'll just go over very briefly, is just sort of a strategy for working word problems in general with triangles, but also with two triangles specifically. And they suggest starting with a diagram, which I've provided for you in this lesson. And it starts to talk about looking for the number of triangles that you would have in a question. So if we look at this triangle here that we've got set up, we actually have three triangles. We have triangle MLK, we have triangle NLK, and we have triangle NMK. Now for us, where we're at in our unit, we haven't done any official teaching of non-right angle triangles yet. So triangle NMK, at this moment anyway, we're not going to be using any of the non-right angle triangle tools at our disposal. Instead, we're going to be focusing on just the fact that we have two triangles here. The rest of that paragraph on strategies really just says that in double triangle problems, you're going to need to find an additional piece of information using one triangle to get a piece of information you can use in the second triangle that will lead you to your answer. So I guess that's sort of a more confusing way of saying that the triangle that you're going to need to get the final answer won't have enough information out of the gate. You're going to have to use the second triangle to find a shared piece of information. And I think they say that somewhere in here, where you have a side that is shared or an angle that is shared. Those are going to be sort of our strategies in trying to figure out how to answer these questions. So let's start here with example 1. We are going to find the length of side MN. So that's this guy right here. This is what we want to find. Let's pop an X on there right now just so we don't forget. There's X, that's what we're after. Now we have some information provided for us. We have 5.8 is the length of LK. We have angle MKL at 25 degrees and angle MKN at 23 degrees. So we need to figure out how to get to this, because there's no obvious way to get here. Now, if we're looking at just this bottom triangle right here, if we're just looking at this guy, MLK, we actually have enough information in this triangle to find some stuff. And what we can find that will be helpful for us is finding a piece of information along this side over here. If we can find ML, that's going to be something that's helpful for us. So let's start with that. I'm going to do just a little shout out, as I normally do, so I don't totally mess up this whole scenario here. I'm going to just draw a little triangle over here, and I'm going to find ML. That's going to be my first thing I'm going to go after. So I'm going to find side ML, and I'm going to draw a little triangle here. Nothing fancy, it's a right angle, and I'm going to copy some of that information over. So we have the base is 5.8, and we have 25 degrees as our angle right here. So this is the side over here that I want. I want to get this guy right here. That's side ML. So let's start by labeling this triangle using our primary trig ratio side names like opposite, hypotenuse, and adjacent. So here's my reference angle. Why don't you go ahead and label these three sides with respect to hypotenuse, opposite, and adjacent. Do that, and then come back and see if you've done it correctly. Okay, here we go. So we've got from our reference angle, we have the hypotenuse across from the 90. The opposite is across from the reference angle, and that leaves us with adjacent down here. So again, I'm going to keep modeling this. If you're not sure which trig ratio to use in any particular situation, I always recommend that you write out Sohcahtoa. And by all means, if you're past this, if you don't need this step anymore, then you don't have to go through it. So what side do we have? Well, we have our adjacent side at 5.8. So that means we're not going to be using sine for this question. And what side is it that we want? Well, it is our opposite side. So that means we will be using our tangent ratio and not cosine. So let's write that out. The tangent of 25 degrees will be equal to the opposite value, which we don't know, over the adjacent value, which is 5.8, if I remember correctly. All right. So now we're going to go on and find the length of ML, which is the x in this equation. So why don't you go do that? Hit pause here. You go try to find out what x is equal to. When you've got it, come on back, and then we'll work through the rest of it together, and you can see if you're right. Okay, so we've got tan 25 degrees. We're going to put that over 1, and we are going to cross multiply. So we have x is equal to 5.8 times the tan of 25 degrees. There we go. X will be equal to approximately, all right, let's pop this in the old calculator here. 5.8 times the tangent of 25 degrees equals 2.7 approximately. And I don't remember what our unit of measure was there. Centimeters, so 2.7 centimeters. So I have found ML, that's going to be 2.7. And hopefully a plan is starting to emerge in your brain here, whereas if we know this side length right here, if we could find this total side length, n to l, we could subtract ml from nl to get nm. That's going to be a sort of a strategy that we can get there. So is there a way for me to find the side length nl? There is. Actually, I'm going to be looking at this time the entire triangle, the whole big one here, and I'm going to find side length NL. So let's try that. Change up my color here. Okay, so part 2, we are going to find NL. That's the whole side length. And again, I'm going to draw that whole triangle out there just so I can use it as a reference. Nothing fancy. So we still have 5.8 down here. But now we have this whole angle here to contend with. And that angle, with those two angles combined, is going to give us 48 degrees. Whoops, that's not 4.8, 48 degrees. And we are looking for this side over here. That will be side NL. So, same as before, using angle 48 as our reference angle, let's label all 3 sides of this triangle with respect to hypotenuse, opposite, and adjacent. So hit pause, do that now, come on back, and we'll see if you did it correctly. Okay, let's get a look. Hypotenuse, of course, is across from our right angle. Opposite is across from our reference angle, and adjacent is hanging out there beside our reference angle. Okay, so let's Sohcahtoa this thing and see which one we need to use. So we're going to write out Sohcahtoa, and as I said, if you're past this, if you just can look at the question and see it, then, well, it's too close, then totally fine. You do not need to write this out. This is mostly just so that you can pick the right trig ratio to use. So here I've got Sohcahtoa. What side do I have? Well, again, I have adjacent, so don't need sine for this one, and I want the opposite again. So I'm going to be using tangent again, not cosine. So let's write this out. The tangent of 48 degrees will be equal to our opposite side, which is unknown, over 5.8. Okay, there we go. So what I'd like you guys to do is work this out and find out what side x is equal to. When you've got it, come on back and we'll see if you got it right. So hit pause. And now you're back. So we've got tan 48 degrees over 1. We're going to cross multiply, and we're going to get x equal to 5.8 times the tangent of 48 degrees. And next will then equal approximately, let's pop that in the old calculator here. So we've got 5.8 times the tangent of 48 degrees, and that will equal 6.4 approximately. And that was centimeters. So now we're on our last step. We know this whole side over here is 6.4. We know that little piece, ML, is 2.7, so we can find MN. That's our last step. So number 3, find MN. Whoop, that's not a letter. MN, there we go. And we can do this because we know that MN will equal 6.4 subtract 2.7, I think it was. And MN will then equal, let's put that in the calculator if we need to, 6.4 minus 2.7 gives us 3.7 centimeters. And now that we're all done, this isn't really a word problem, but it doesn't hurt to sort of sum up what we found here. So we can say, therefore, side MN is 3.7 centimeters. And there is our therefore statement. There is our problem. So hopefully this approach was helpful to you, that you can sort of see that you need to find shared things between the triangles to get enough information to figure out what it is that you're after. That's certainly the hallmark of double triangle questions, is that you won't be able to do it in just one step. There's going to be multiple steps. You need a bit of a plan. I know that is well reflected in the homework. So you have some homework down here. Good luck with the homework, and we will see you in lesson 5, which is the start of our non-right angle triangle exploration. We're going to go to the sign law, but let's just finish up the double triangle questions first. Good luck.